two blades. These are two different blades. Okay, the two blades are having a flat edge, flat round one, and it is spherical in shape, and the outside part is little bulging. It is flat to this particular side because the air when it is rotated is having a frictionless area. So this is a fin. This is a turbine outside plate. This is left side, this is right side. As we are keeping it like this. Okay. This turbine, when it is made like this, okay, the total turbine will be in this shape. In this shape. The turbine will be in this shape, and this turbine is rotated as a turbine what you see like this. This is also rotated like this. In this way, the width of the turbine is more, thereby when the turbine rotates, it is having an opposition with the air and water. So thereby the RPM of this turbine, this design is maximum 825 to 840. So the RPM of this particular size, of this particular dimension or this particular design is coming only for 800 to 825 or 830 RPM. But when we make the same design, removing this particular fins, these are the fins, when we remove this and when we make the turbine like this, both the blades, this blade and this blade, this turbine, this blade will be like this. So it will be like this, and the shape of this turbine blade will come like this. This is the outside part. So these two blades when put together, the bottom side and the top one, this side and this side, it is having a pattern of the width is more, thereby when the turbine rotates, it has to counteract the forces of air and water. Thereby the RPM is curtailed. We cannot go in for high RPMs on this particular issue. In this particular regard, when we are putting the two blades of this particular side and this particular left hand and right hand side, the turbine shape ultimately will become like this, and it will spin very easily inside the water. So this is a new technology where the turbine is designed as a saucer, as a particular design which is there in the discus throw. It is like a discus. In the application of athletics we use discus throw. So the discus is perfectly balanced and it can cut the air and cut the water in a precise way. So this is totally designed on the aerodynamics of the discus throw. Thereby this turbine is a new turbine, new design. To this particular system, the fins are coming to the bottom side. The fins are coming to the bottom side. The fin is coming like this. The fin is coming like this. So water is hitting on this particular edges. So this particular fin is made to stand in this particular sector. This is a canal. This canal is having the fin and the turbine. So water is hitting. Water is hitting this area, and this will be rotating like this. So the water which is hitting on this particular edges will cut this particular thing, and by the pressure of this particular thing, the fin of this turbine is moving to the top side. Thereby the turbine spins and it rotates at 1600 rpm to 3000 rpm. So this particular design will help in high speed rotations of the alternator and of the turbine. The turbine can be 20 tons, 30 tons or 60 tons, but the design is the same. So thereby the flow-based mechanisms, we are concentrating only on the flow-based systems. The flow-based systems is more efficient because water is always flowing in various canals, various pipes, various activities. So here we are concentrating only on the flow. The flow is very important, whereby the land requirement of this particular system is very little, and in a little area, for example 25 acres of land, we can generate 1200 megawatts every day. So this is a flow-based mechanism. Water is used again and again, and in my workshop we are designing all these particular systems. Thank you. So this is the fin bar. ఇట్లా వస్తుంది అన్నమాట. సో మనకి ఏమవుతుంది తెలుసా? అవసరం. So in this way, what we do is we take only 3 inches. 3 inches ఉంటుంది fin. ఇంతే ఉంటుంది height. Okay. So ఇట్లా ఉంటుంది. Back side will close this. Okay. Back side ఎప్పుడైతే క్లోజ్ అయిపోయిందో ఎంత వెయిట్ ఉంది? మీద పట్టుకో.